Ladies and gentlemen, this is Joe's Classic Video Games back with another cool pinball repair video for you this evening. If you haven't been watching, we've been working on this cool Williams Lucky 7 pinball machine. This was their second ever solid state pinball machine. The first one was Hot Tip, a horse racing game. The second one was this Lucky 7. We've had one of these in before, but our buddy Rodney brought us this one and the thing was parted out. So we're parting it back in. I'm tired of all this parting out stuff, people. People taking good machines apart and parting them out. We're parting it back in, so we're going to fix this sucker. And in the first video, we worked on the power supply a little bit, got it all up and doing its thing. On the second video, we worked on the playfield, got it all pretty good. And then on the last video, we were actually able to repair the old battery damaged, crusty, original MPU board that was still mounted in the game. Now this thing had the original batteries on it. They still said Mallory on it from 1977 or 78, whenever it was, right? So if you didn't see that video, go check that out. And at the end of the video, we were testing out this CPU, this MPU, with Leon's test ROM here. Gentleman Leon, way back in the day, invented a little test ROM to check these out. And we believe that the CPU is working fine. But now we need to mate the driver board back in, which is what runs everything in the machine. So we're going to do that in this video. So if you've got a system 3, 4, 5, or 6, I guess there's not really 5s. A 3, 4, or 6 Williams pinball machine, or a 7, this will help you hopefully. So I've got a driver board in the back we're going to check out, and we're going to see if we can fix it and test it with this test Eprom. If you want a copy of Leon's test Eprom, you can get it from pinrepair.com. Clay kind of consolidated a bunch of that information many years ago, and that's where we learned how to work on these. So the thing is up and running right now. That's why it's blinking those LEDs. So it's basically blinking all of the outputs, and once we attach the driver board, it's going to blink all of the outputs on the PIAs on the driver board as well. So we'll do that here shortly. Let me show you the driver board that we've got that we're going to attempt to repair and put in this beautiful machine. So this is the System 3 through System 7 driver board. Now this particular one, I just got out of a box. Whenever we got this game, it didn't have this board in it. It did have the CPU. It didn't have the power supply. The CPU had all that battery damage. We fixed it, we believe. You saw it blinking. It's doing its thing. But I pulled this out of a storage box that I had. Also, the power supply came out of a storage box. So in the first video, we did the power supply, but we're up to the driver board. It says won't boot. That looks like my handwriting. I don't remember writing it on there. But won't boot. Now, why would this not boot? Well, the way the thing's laid out, there's this connector up here. They call this the interconnector, or the interconnect. There's a 40-pin interconnect. That basically plugs into the MPU board and is basically the other half of the MPU board. So when you're running the regular software, not the test ROM that we're running now, when you're running the regular software, that CPU is talking specifically to these 3 PIA chips. Peripheral Interface Adapters, 6821s. One of them is then going to control all of the solenoids. So from here over is all of your solenoids. One of them is going to control all of the lamps, the lights and stuff that turn on. So from here over is all of your lamps. And then this one in this area controls all of the switches. So what happens is that CPU chip talks to these, and there's a little bit of a handshake going on. And so you get information passing across this connector. This particular one has been replaced. And it looks like by me, those are pretty new. So that would be the first thing that you would do. It appears that I've done that at some point. Okay. What would lock it up? Well, usually if this causes the CPU to not boot, usually it's going to be this PIA. This is the switch one, the switch matrix, and that's typically what's going to cause problems with the game booting up. Now, I could be completely wrong, but that would be my guess. It's also the only one that hasn't been socketed yet. You could have a situation too where the socket was installed bad, and so maybe a couple address lines are shorted together or something, and that's messing it up. But I would just guess that PIA is probably messed up. So what we're going to do is we're going to go ahead and mate this to the CPU and then turn it back on, and then we can check these PIAs with that Leon's test ROM playing in it. We talked about Mr. Leon in the previous video. He was a gentleman, old school pinball repair guy that passed away in 2012. But before he did, he wrote all kinds of like little test programs and stuff for several different types of pinball machines, including these early Williams ones. So his test Eprom basically just tells all of the outputs of the PIAs to flash on and off like this. So it makes it really valuable on checking something like this. So we're going to plug this in, and then we're going to check the outputs of all three of these and see if one of them's messed up. Okay, so we have put it back in there on its interconnection, which I replaced on the previous video on the MPU there. And the only connector we have plugged in is the power going to the MPU. That power is going to travel over that interconnect board and power up this board as well. I don't have any of the outputs plugged in. And over here on the power supply, all I've got plugged in is the 5-volt connector, basically, that's running over to that. So if you were to plug in the lamps, for instance, with the game not running code, not running the actual game code, it's going to turn all the lamps on all at the same time. And this particular model of machine, these early Williams games, they strobe the power going to the lamps. So they send out 18 volts to run 6-volt lamps. And they strobe it a certain way where that works fine. But they don't whenever you're using the test Eprom. It's going to send 18 volts out. So it would burn up every lamp in this game if I had the lamps plugged in. So we're not going to do that. Same thing with the coil. The coils. It's going to tell all of the coils to come on at the same time. It's going to pop 10 coils on at the same time, right? Or more than that, 15. So we don't want any of those plugged in, so they're all unplugged. If you're going to test it in the game, that's how you want to do it. So basically, we're doing it as if we're testing it on the bench. All we have plugged up is one power line to it. Okay? So when I turn it on, I don't know that it can even lock up Leon's test ROM. So it says won't boot, but I don't know that it can screw up his test ROM. It'll probably work. So let's see what we got. Yeah, so it's still doing the same thing. So that's what it's supposed to do. It's blinking the outputs. The reason the LEDs are blinking is because they're part of the outputs. It's just blinking everything, including those LEDs. So I'm going to hook up a logic probe, and we're going to check pins 2 through 17, pin 19, and pin 39 on each one of these 3 PIAs. We already did that with the PIA up here and found it was fine. So we're gonna check that. Now those are the outputs. You don't really need to check the inputs, because if the output is there, the input's there. There may be a few exceptions to that, but in general you just need to check the outputs, because that's telling you that the software is capable of turning the outputs of the PIAs on and off, which is how the whole thing works, right? So let me hook up a logic probe and we'll test through them a little bit. All right, folks, so let's see if we can test those, if you can see it at all. Pins 2 through 17. See how the test Eprom is just making it blink? Uh-oh. Uh-oh. Pin 2, 3, 4, 5 is stuck on. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19. It's kind of doing something, but that's probably messed up. And then 39. 39 is working. I think that chip's bad. Pin 5's messed up, man. Let me see if I can swap another one in, and then we'll test it. All right, I popped another one in. Now, it could be the input is messed up. It also could be that the logic chip that connects to is messed up, but we'll see. 2, 3, 4. Yeah, see, the PIA is fine. But that one's still screwed up. So 5 is messed up. 6, 7, 8, 9. Let's see what 19 did. Remember, it was messed up too. We'll just keep that in mind. So basically, pin 5 of this has some kind of problem. It could be the input, or more likely it's the whatever chip that controls. So let's move over to this lamp one. 2, 3, 4, 5, 6, 7. They're starting to blur together. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, a little different. Well, now it's the same. See, there's 19. It's a little weird too. It's just, I think that 19 one just is weird. Okay, and 39. Okay, so that one's probably fine. This one, there's something going on with pin 5. Okay, now the switch one, you can't check these the bottom half of this switch matrix one. You had to ground these pins to do it. They'll just test as low if you don't. 5, 6, 7, 8, 9. But the top half you can. 10, 11, 12, 13, 14, 15, 16, 17, 19 with the weird thing again, but that's just how it is, I think. And finally, 39. Okay. Seems to me like it's that one, pin 5 is our problem. We still might have this, but we have to, you had to hook up a ground or something to it. Okay, let me see what 5 connects to. I have these big blueprints. Pin 5 of that PIA is actually solenoid drive 4. Connects to pin 1 of IC1. So we need to look at Q21 and Q20 and pin 1 of IC1. All of that's probably fried. Alright, so this is the transistor in question. It's fine, as is the pre-driver, or the whatever that is, the other transistor. They're fine. This is IC1, it's a 7408. These are also 7408s. When I check that pin 1, this is a little trick you can do with 74 series chips. You can just check, you know, they all have like gates in them, basically. They have a relationship, you know, voltage drop. If I connect pin 1 and 2, it's pretty much shorted. 1 and 3 are shorted. 1 and 4 has a voltage drop of 0.5. 1 and 5 is shorted. So I've got all kinds of stuff shorted as if that chip has just failed. If I check another one, like this is the same, you know, it's a 7408. 1 and 2 are not shorted. 1 and 3 are not shorted. It's just I get completely different readings. So this chip, you know, I mean, this is not completely a perfect way to test it, but this chip is probably just bad. The transistor itself tests fine. Usually it would be your transistor. But if the transistor was bad, that would not typically screw up one of the pins on the PIA, because basically, you know, we're running backwards, but the transistor is at the end of the line. It's turned on by the 7408, which is turned on by the PIA, which is turned on by the CPU. You know, so basically if you get like a power, you know, something shorts or whatever, the coil shorts, it would screw this up. And then sometimes it'll screw up the pre-driver transistor. And then sometimes it'll screw up this chip. But rarely does it go all the way back and screw up the PIA, although it could, right? Well, we've got a situation here where the PIA is fine, the transistor is fine, but this chip is all screwed up. It's got different pins shorted, and I guess it just failed. I don't know. So I'll take it out and we'll try testing it outside of the board and see if we see anything weird. All right, so I took the thing out. Okay, I know you can't see everything, but you'll be all right. So I'm going to check the actual chip outside of the board. I'm going to show you another little trick you can do too. Is it good enough? I'll show you another little trick you can do too. So here's the chip. Yeah, look at that crap. Pin 1 and 2 are dead shorted to each other. 1 and 3 are not. 1 and 4 are not. 1 and 5 have a voltage drop. 1 and 6 voltage drop. But 1 and 2, dead short. Okay, so here's the little trick you can do. Whenever you run into a situation like that, did something on the board do it? So what you can do is you can just check the board without the chip in it and see if you still have the short on the board. So 1 and 2 are not shorted together on the board. 1 and 3 are not. 1 and 4 are not. 1 and 5 are not. 1 and 6 are not. So I'm getting no problems on the board. I'm getting slightly different, but problems on this chip, you know, so I can, with a pretty high confidence, say that this chip is the problem. When it's on the board, it's short and crap together. So so my whole point is, if you're pulling out a chip and you think that's the problem, just check the board without the chip on there. So remember we changed this, and then we had the same exact problem. That's because this wasn't the problem. It just looked like it was the problem. There was something else on the board causing that pin 5 not the wigwag, right? Which we've decided is this chip, the next thing that it connected to. So we're in the same situation now. This chip is screwed up as I tested in the board. Well, now I've removed it, and now when I look at the board, we don't have the problem anymore. So, you know, I'm basically, we're proving that this is definitely the problem, right? So that is a really ugly chip. I guess it just failed, right? But if you look, they've replaced some other ones too. Here, you want to go in high def? Let's go high def. Now, I didn't do this, people. This isn't me. What the hell's going on here? I didn't do that, people. And there's where we replaced the one, or we popped out the one. But look how bad this chip looks. Kind of rough, right? Oh, look at it. It says 7914. It's the 14th week of 1979. It's time to retire it. Let me see if I got another one from the 70s I can pop in there. All right, so we're going to put that back in, And then we're going to go put the board back in and see if number 5 will twinklate for us. All right, folks, today's video is sponsored by eWin. Now, you may think, why are you doing a sponsored video? It's because of my brother Joey here. Joe, tell him about how your back hurts, your knee hurts, your leg hurts.
I've got problems.
He's got problems. Joey's lost, somebody in a video previously was saying you lost some weight, Joey.
Yeah. Well, my back's been hurting. I think I pinched my sciatic nerve somehow. But anyway.
We had a chair that he sat in here at the shop, and he felt fine if we had that chair. And then we had a customer come in and break the thing, sitting in it. So the chair fell apart. So we need a new chair, and this company, eWin, got a hold of us and said, hey, would you like to try our chair? And we said, why, we sure would.
Yep, the timing worked
The timing was perfect, and this thing is more heavy duty than the one we had. So we're going to take it out of the box and see if it's any good. This is the one that we got. Look at this. The first thing we noticed is it's a lot heavier than the other chairs that we've had. We've been getting, you know, decent office chairs. This one's heavy, which is good. Joey really likes the bottom. Sweet. The back's so heavy I can't even hardly pick it up. Comes with a nice little instruction thing. Joey so far is totally impressed, but we haven't sat in it yet.
It's even got metal screws.
It's like you're building a 1959 Cadillac. Lots of metal.
This looks like quality so far.
Steel and stuff. It's kind of cool they use like hog rings like you use on car upholstery. And it's just heavy duty. There's some strapping down here too. Pretty nicely made. It seems to me it's kind of like it's a decent car seat, like that style of construction, but for a gaming chair. Yeah, we about got it finished here. Looking pretty good, Joe.
I think I'll save these for later.
You were supposed to wear those while you put them on.
It's fine.
Oh, while you put it together. All right, show them the drop. Whoop. So the hydraulic thing works pretty good. Okay, abuse it a little bit. That's pretty good. All right, do the lean back. All right.
Oh, Lord. The world about fell out from under me.
Did it scare you?
Yep. Seems to be pretty nice.
We like it. Very cool. All right, so we don't know long term how well it'll work, but let me show you the ones that we were using before. This is what I can't believe. They actually gave us extra hardware. There's one extra of each size screw and an extra cap, and it comes with the 2 Allen wrenches you need. Pretty impressive. Here's the chair that we were using. Now this is what you call, what do they call this, Joe?
It's a tanker chair.
Tanker chair. They used them on like battleships.
Yeah.
Navy had them back in the day. But it's old, folks, and there's no cushion. Then we've got this one. This is just your typical office chair. It's okay, but again, not much cushion. The back can't be adjusted. And then we got this one. It's pretty impressive so far. What do you give it, Joe, so far?
I give it a 9 out of 10.
9 out of 10. That's pretty good.
And I don't give nothing a 10.
He don't give nothing a 10, so it was impossible to be a 10. So you might want to check them out. eWin.
I mean, seems nice. I've had trucks with worse seats than this.
He keeps going on and on and on about it. I can't get him to shut up. One more time. Pin 2, pin 3, pin 4, pin 5. All right, so they're all twinkling, doing their thing. I don't think I'm going to worry about the switch. Well, we know there's a problem though. I don't know if that chip was enough to tank the whole board where it's saying it won't boot. Let me see if I can figure out how to put the grounds on it where it'll let me test that other PIA. Okay, so basically I've shorted the output pins to ground, just a couple of them, and we'll have to move it around, but yeah, there we go. 2, 3. I gotta move my jumper. 4, 5. 6, 7, 8, 9. The top ones you don't have to. Yeah, that PIA is fine. Unless we've got a problem with pin 17, you know, all three of the 17s were doing weird stuff. I can actually check the 17 up on the top, though. I mean the 19. I can check the 19 up on the top. It seems different. But I don't know. I think we're probably good. Okay, so was that one chip, IC1, that little 7408, was that enough to keep the whole board from booting? Where I wrote won't boot on it? Maybe, or maybe I wrote won't boot and then I started working on it and I could never get it right and I just left it saying won't boot. Or maybe that's not even my handwriting and somebody else wrote that. I don't remember writing it on there. Maybe somebody else wrote it and I'm at a point in my career where I can find the stuff a little better than they could be. Or I could be at a point in my career where I can find stuff a little better than my old self could. Could be that too. All right, so we're ready to burn EPROMs, pop them in the CPU and see if we can get the whole shebang to do what she's supposed to do. All right, so since it's such an old chip, these are 2716s. I'm breaking out my old pocket programmer that hooks up via parallel port on this old laptop. And basically the old software for these old machines you can still get from Williams. If you go to planetarypinball.com, which are the people that have licensed the rights from Williams, which by the way Williams owns Valley, you know. The people that have licensed the rights from Williams, they provide the old software for free on their website. Now, they're just little tiny files, but still, they don't have to do that. You know, in modern electronics, you can't get your hands on any way to repair anything old. But Williams Pinball actually lets you have their old software. So I am programming the 3 little chips we need as we speak that we can pop in the original MPU from 1978. And we'll see if the thing will decide to boot for us. All right, folks, so here's our 3 new chips. I went ahead and put a battery on it. And I ran into all kinds of problems. I'm going to show you here in a second. I've been working on this thing between the last part of that video and this part of the video for like 2 weeks. So I'm going to show you what I figured out. You get in these things where you go down the rabbit hole. And it ain't good, people. All right, so let's see if it'll cooperate. So you see how the lights turned on and then turned off. I've got some lights on the playfield. Now this particular game doesn't have an attract mode. This was early. And I've only got the one display plugged in. Yeah, I've only got one plugged in and we are getting some score stuff, and we're getting a couple lights flashing here. So this one I think is game over or high score to date, and this one's saying one can play or something like that. So I think it's actually booted. But let me go show you what I had, what I figured out. I'll show you another board. So this is a similar board. It's just out of the machine, so it's easier for me to show you. I want to show you something in particular that's very interesting. So this is a revision 4. This is another one that I've just got in a box. I don't know if it works or not. So here's what happened. Whenever I put the 3 ROMs in, and the board would not boot. And so then I thought, wonder what happened. Everything looks good. And I started checking all of the traces on all of these chips. And everything was cool. And so then I put the test EPROM back in, and it would come up and just lock the lights on. And I thought, well, something screwed up. What in the world? And so I started probing the CPU to see if it was awake, and it was. Like some I was getting activity, and then once it starts running that test thing, it starts turning on and off a lot of the outputs of the chip, or I don't know. I guess it's doing it on the address lines, but it turns them on and off, and that's how it's telling the PIAs to turn on and off, like we talked about. So it's going to turn lights on and then off, on, off. And you really don't want it hooked up where it's doing that with the lights because of the way the board's made. But it's a way that you can test the PIAs. So I checked, and this PIA up here was working. It's on and off, on and off, on and off. But the LEDs were stuck on. So I was like, man, something failed. So I kept messing around. And I get so damn deep down the rabbit hole whenever it was much simpler than I thought, right? So I'm looking all over the place, and I kept thinking that it was working and that it was running the code, but that it wasn't flashing these LEDs right. So I took the RAM chips out. Okay, maybe a bad RAM's messing it up. Nope. I swapped the PIA because it wasn't socketed, or the socket was bad, whatever. Like I said, I've been working on it for 2 weeks, so I can't remember, but I swapped the socket. Then I swapped the socket on the CPU just to make sure, because they were Scan-B sockets too. Those are crappy sockets like we talked about. And maybe in the previous video. So I'm chasing my tail, and I let the thing sit for a while. And then I come back to it and I think, okay, I'm just going to start at the beginning. I've replaced a bunch of this stuff already. Maybe there's a problem with the address lines or the data lines, right? And I check, and I finally freaking find it. So let me show you what I found, and it's real common on these, and I'm going to change the way I work on these from now on. There are two chips here on this sucker. See how it's a MC8T28, 8T28, 8T97, 8T97, 8T28. This one's been changed. So an 8T97 is the same as a 74LS367. So you can swap those. Those are your address buffers. Okay. I'm looking at the back here. This isn't going to show it the same. Well, this board's slightly different. So basically, I had this problem where I can show you on the schematics. They have this weird thing where they have these little data buffers that you don't need. But you needed them if you had the old proms on the board. They needed it. But the more modern EPROMs, which is literally like the next chip that came out, you don't need them. So you can just remove those chips, but then you have to jumper it together. So I'll show you on the schematics, since this board's slightly different than the other one. Okay, here's our big, huge blueprint status schematics. Okay, so here is the CPU. Here's the 6800. And then the data lines run through these 8T28s, 8T28, 9 and 10. Now this is, everybody has known this for years, and I knew about it, but I was working kind of on old information. I'll talk about that here in a second. So here's the problem. The data lines run through this, and this is just this old school buffer. Now if you look what it says. One of the lines, like let's look at D0. It runs into pin 2 and pin 4. And then it comes out pin 3. That's hard to read, but that's what it says. And then the next one runs into pin 5 and pin 7, and it comes out pin 6. So it's just this weird, antiquated design. And you need those if you've got the proms on the board. The next chip that came out, like the 2716 or whatever, doesn't need it. so you can cut these off the board and just throw them away, because what happens is the outputs die. And that's what was wrong with mine. D4 was missing. Pin 3 was gone on IC 9. So you don't even have to replace it. You just cut it out and throw it away. I don't even know if there is a modern replacement, but it's unnecessary. So, but then you have the problem where the data lines come out and they just stop here. So you have to short these lines to this side. Okay. Now I have never really done this much. I've worked on a bunch of these, but I never really did it. And I'll tell you why. And I'm saying this with all compliments. You know, I'm not trying to say anything bad here. I learned everything that I learned from pinrepair.com, which is still active. You can go read it right now. The Pinball Ninja himself. Clay, his website is awesome. Awesome. So years ago, whenever I learned to work on these things, I learned step by step, but through what Clay teaches. And on on his website, or his old school guide that I've had for years and years and years, he says that usually he doesn't replace these if they're not obviously wrong. So he doesn't do it as a preventative maintenance thing, right? And I've never really had one of them be bad. But I started thinking about it after I found this problem. He wrote that like 20 years ago. So these chips are 20 years older now than they were then. So from now on, I think I'm just going to replace them, because I'll show you how easy it is to do. Because they cause problems. So the problem that I ran into, and what cost me like 2 weeks of thinking and working on this thing, is that I've never seen one of these go bad, and I was way down a rabbit hole looking at other stuff. It died while I was working on the damn thing. So it was working fine at first. That's why it was running the test Eprom and everything was cool. But somewhere, me taking it out of the machine, putting the new EPROMs in it, and then putting it back, the damn thing died, right? But I was able to find it. It was also intermittent, so it would work after a little while, or sometimes you leave it sit there and start working. So those two chips are these two, this one and this one. Okay, now, if you remember what we were just talking about, pin 1, and let me make sure I got the right pin. Yeah. Pin 1 is right here. I don't have anything around to use as a pointer. This is cool stuff to me. Pin 1 is right here, and that's going to be 5, I guess. It might be ground, 5 or ground. You can see that it ties into pin 15, right? And then it runs up here and does the same up here, pin 1 and pin 15, and keeps on going. Okay, and then pin 8 appears to be ground, as does pin 16. I may have those backwards and it's the other way, but I don't think I do. Okay, so remember the first D0 came on pin 2 and pin 4. Look how they have them tied together. That's just so weird. It must be a NAND gate or something, you know. I don't know, but I don't think it's, I don't know. So 2 and 4 are here, and the output is the one in the middle, pin 3. Okay, and then 5 and 7 are the input of the second one, and pin 6 is the output. And then 9 and 11 are the input of the next one, and pin 10 is the output. 12 and 14 are the input of the next one, and 13 is output. So what I'm saying is, if you cut the chip out, just take it out of the board, all you have to do is jump this pad to this pad. Or hell, you could jump all 3 of them together if you wanted. Right? And this pad to this pad, and this pad to this pad, and this pad to this pad. I just did it with a ball of solder. Really easy. And so and of course I removed the old chip first. So once I did that, your data lines that are coming from the CPU here are running into their inputs of this chip, and then are jumped directly to the outputs of the chip and run off to the EPROM. That was the whole freaking problem, which is like a simple problem. And like I said, if you've worked on a bunch of these, you've probably ran into that before. I've never had one that was bad, I don't believe. So you learn something new every day. So from now on, I'm just going to cut those out and replace them. Clay said he doesn't usually mess with them, but he said that 20 years ago. So I might email him and see if he's changed his mind. All right. I will, we got to go mess with these displays. So I'm going to plug in the other 4 displays and see if, see what's working and what's not. All right, the camera is tripping, but let me, if I back up, you can see it better. Look at that. I fixed it with a step. The only one, so player 3 is not working, and the bottom line of the master display is not, the bottom line is not there. The bottom segment on each digit. But 1, 2, and 4 look good. The glass in 3 is probably bad. And then it might have a bad glass on the master display too, which isn't cool. You know, you can't get the glasses right. But we'll see what we can do. All right, folks, that's it for today. So far, we've got the game actually booted, the MPU working, the driver board working, the displays almost working. So next time we'll work on the displays and go all the way through that and check out the blinking signal on them and all of that. So I've got 2 display boards that I want to fix, and we need to figure out a 4th slave display for Rodney. So hope you enjoyed it so far. Leave your comments down below and let us know what you think. Make sure to give us the thumbs up for filming it for you. By the way, we still got this old messed up back glass here on the wall, obviously. We put it on the red background there. It makes it look cool. I think we showed that in an earlier video. But leave your comments below. Let us know what you think. Hey, check out my brother Donnie. If you don't know about his channel, there's a link down below. Our brother has a channel. We work on pinball machines, arcade games, and jukeboxes. He works on old buildings, old vehicles, things like that. So we'll see you back here in a couple days with the next installment where we'll start messing with the displays. So hopefully if you've got a System 3 through System 7, this will help you fix yours. Lucky 7.